Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have the function f is equal to e to the x times y square. Now we have to compute the first partial derivatives of this function and then evaluate each of them at this point natural log of 3 comma 2. So using the symbols, what we really have to find, we have to find the first partial derivatives. So to find fx, this is the symbol we use to mean is the partial derivative of the function with respect to x, and we have to evaluate it at natural log of 3 comma 2. So this is the one of them that we have to compute, and the second one is fy, which is the partial derivative with respect to y of this function, and also evaluate at the same point. So these are the two values that we want. Okay. So let's start with fx, but first we can't directly figure out at ln of 3 comma 2 at that point. We have to first find the partial derivative of the function in the variable x and y. Okay. So this means this is the partial with respect to x of the function e to the x y square. Okay. Notice that this is a product of two functions, so we have to apply product rule. Okay. So let's do that first. Product rule says you keep one of the functions, say e to the x, as it is, and take the derivative of the second one. In this case is the partial derivative of y square. Then add and then switch the role of the two functions. So keep y square as it is, take the partial derivative of e to the x. All right. So let's see what these are going to be. E to the x remains as it is. Now, function is y square. You're taking the partial with respect to x. And remember, for partial derivative with respect to x, y is a constant. And therefore, y square is also constant because it's with respect to x. So derivative of a constant is 0. For the second one, keep y square as it is. Now, you're taking the derivative of e to the x, and it's a partial derivative with respect to x. Same variables, so the derivative of e to the x is e to the x. So this expression is, this first term is 0, so you will have y square e to the x. And notice it's the same as the function itself. Okay. And let's compute the partial with respect to x at this point right away from here. So we already know what the derivative is. Now we have to evaluate that expression at this point. Now notice that this is your x, this is your y. All you have to do is plug in x equals natural log of 3, y equals 2 in this expression for the derivative. So y is 2, so you have 2 square, and times e to the x, x is natural log of 3. Now we know 2 squared is 4. What about e to the natural log of 3? Remember the inverse property of exponential and natural log function? So when they are next to each other, they cancel. So e to the ln of 3 is just 3. And so the answer is 12. So this value is 12. Okay, so you computed the first one. Let's move on to the second one. Now we have to compute the partial derivative with respect to y. So let's figure out the derivative first, and then we'll evaluate at that point. Okay, so this is equal to the partial with respect to y of the function e to the x y square. Again, this is a product rule you have to use because it's a product of two functions. Do the same thing. Keep one of the function as it is and take the partial with respect to y of the other function y square, and then add to it and switch the role of the two. Keep y square as it is and partial with respect to y of e to the x. All right. Now be very careful, right? This is partial derivative with respect to y, so x is constant. Now when you see the same variable, it's fine. Then notice that this function is y squared, there is no x, so you can compute the derivative of y squared as 2y. For the second term, now notice that you have a function in x and you're computing derivative with respect to y. It's a partial derivative, x is constant, so e to the x is constant, and so the derivative is just 0. And so your expression is 2y e to the x. So let's figure out, now we have the partial derivative of the function with respect to y. Now let's evaluate at this point. So what is fy of ln 3 comma 2? Now notice as before, this is x and this is y. So all you have to do is take the expression of the partial derivative and plug in x equals natural log of 3 and y equals 2. So let's do that. So 2 times y, and y is 2, times e to the x, and x is natural log of 3. Okay, so let's simplify that. 2 times 2 is 4. And e to the natural log of 3, remember again, because of the inverse property of exponential and natural log function, they cancel each other, and then you end up getting 3. And therefore, 4 times 3 is 12. So the answer for the second part is also 12. So the partial with respect to y at this point is 12 as well. So that completes the problem. Thank you.